Hello guys, how are you? Yeah, similar topic here in chat. Yeah, light you can see wave. Yeah. Mona re go lebeletse mo le ne general properties of all waves. I get ya ha re lebella light. Ta bua ka light. Hela. Yeah, these are the specific objectives from the syllabus. Remember, at the end of this topic, we discuss all these objectives. Me gape go dimo ga mo se se botlhokwa thata ile gone gore go tlhaloganye ebile o ka kgona le go araba dipotso tsone tsa nyenyane tsa light tsa di specific objectives tsone tse di hatse so re ta nna re botsa dipotso the exam questions. How now you have to come back to that specific objective. Okay. Yeah. Let's start by refraction of light. Refraction of light. Refraction is the bending of light as it passes from one transparent medium to another of different optical density. When a light moves from one medium or material to the other one of different optical density, its speed changes as well as the wavelength, and this causes a change in its direction of travel. So, I want to look at refraction ke go benda ga light ha e tswa mo one medium to another medium. Medium at is transparent gape kana re different mediums o mo ta bona le high density mona le low density. Density ra optical density. Ka ha light yone e bona go le dense ka teng e seng density ja gore nya ha ke beile ha le ke a bona ke tsaya mass le volume ke calculator density nya ra density ya optics. Optical density. So example re na le yone ke ta kopa le re wena o kola teng ko ire o ka tsaya metsi ba tshela mo galasing o tsenya sengwe se se straight na ka nna a ka toro tsenye liswana ga liswana mo ithele gore lone ga le straight o khona la o sa bona senta gore indeed wa go lebe ga e ka re so sa teng se kgaogile kana sa benda se tsena mo metsi a kra bona gore this is a pencil a bona re tayana mara se nna tsena mo metsi nna ga re boela ka e be tayana fa pa bona re le size ya teng a si ya ke this is the bending of light. So refraction are super ray ya teng ya go nna ya go taela ka bona yana ha it's ena because this is glass, this is denser, this is optically denser. This is an S. Optically denser. This is the glass, this is air. So how dense for light or heat it through. So here in light it's an libero la hokotsega. La hokotsega ka gore ninyane wavelength ya teng e hokotsegile. Nka supa helana gore wavelength speed frequency. Remember frequency I can change frequency more thing higher light day so na le frequency ya the source ke sona se na re se bua go general properties of waves. Frequency I change and na tshwana you the pedi ke tsone tse di ka change is the waves travels wavelength and speed. So wavelength I change or the speed is rain so change. So that's it. Hana redefine this. Hana how o kana ke ya straight ha bona ke ha gona le point of incidence teng ha gona le point of incidence teng ke gona le gore wa go iraeng this normal line gore ha ona le a ke irele ka ha ona le maybe glass block o bo super ray times yan a ke re gore e strike this thing at this point gone we ira mo go teng normal line is at 90 degrees to the surface I get 90 degrees here normal line re irela re tere bona gore go go iragalang after this ray is strike I get yana mona bero bitsa re ke incident angle I get the angle of incidence as the angle of incidence okay which is between the normal and the incident ray homoki incident ray okay yeah this is the incident ray which is AO okay yeah no how is na night namote ya go benda let's say bender in this direction hana renale angle of refraction key angle of refraction in between the normal line and the refracted ray and the normal line. So when I talk about these two angles, it's always between the normal and the ray. Something of this kind, no. Kind this, no. It's not. Okay. So I wanna read. So yeah, no. Se receive review some facts about refraction of light from one transparent medium to another transparent medium of different optical density. Okay, yeah, so let's do that. Here are the facts about refraction. You see these two, particularly these two statements, mean 1 and 2 has also the corner. Calculation 1 and 2. Then with this one, yeah, number 3. Here normal calculation why is the ray not refracted? The ray along the normal is not refracted. I get A. Other one number 1. A ray moving from less dense, optically of course, medium to a more dense medium, e.g. air to glass, will bend towards the normal. Will bend towards the what? The normal. Let me remove this normal. It's similar from the beginning. Key limiter every time again. So let me do that. Yes, inside the normal line. The incident ray will strike this glass block thing. Normal line. Normal line. Scan I got it's not that normal line. I get So here is my ray. Kilikili go ira ile straight. Ga kologela wena wa go resign rule la get le nna ke bona e ka re ke tsenya ga dingalo. I will use line ke sa receive freehand. So A ray will always have a direction. So ke tshwanetse gore ke tsenye arrow tse di supang gore ray e tswa kae ya kae. Mme be re okay, ka re strike le gone re kopa gore gone ha re ray normal line. Ke a boelo ke ira ya latelang ke tla dirisa line simple. Be ke reng normal line ke yone akere so this is a what incident ray ka re ke incident ray gore re angle ya hae ta nine angle of incidence ke angle of incidence akere yang sa ran se khoa ka such a ray will bend towards the what? The normal. That's the reason why the normal line. Okay, ke kopa go supa gore ha ne sa bend ne go tsamaya. We should always be thinking about it. Ha ne sa bend guys ne go tsamaya na ke ke le ka go ira it straight ya. Ha ne sa bend line. Ha ne go sna glass block. E ne go tsamaya le akere ke sa re ga bona ya no ga ha ina go tsamaya le gone ya ra iso re light travels in straight lines. Akere light will always travel in a straight line. Ya no ka re ha ya no change a medium straight line ra mo at the same medium. Akere ya no go ra gore ya go bend towards the normal. Where is the normal? Here is the normal. Go ra ya go tsamaya between the normal and this line le gore ne tshwantse tsamaye le teng. Let me try my best. Good. Okay. It towards what? The normal. Homo ke mo refracted ray. Ke yone refracted ray. Yan mo go ra gore ke mo ke angle of refraction. Go ra ke nna r nna angle of refraction. Okay. Ya no are leveling number 2. Like I said, ke tla leka go irisa inenya the line gore go nne a little bit neat than this. I don't like this. Ha ne ke batla go ira sketch la re khona go bona sentle mme ya gore re ira yang akere yeah. Allow me to use lines now. So, what are we doing? 2. A ray moving from a more dense medium to a less dense medium will bend away from the normal. What are we more dense to less dense? Which one is more dense? Is the glass. Less dense ke air. So our small ray arona is okay glass. Okay, here we are. I'm using this line. Good. Q&A line arona. So what do we do? Rahwata go supa gore gone ha ya no normal line ke ya hakai. Let me do that. Kana re normal line e tshwantse re nne yang at 90 degrees to this, right? Ke a go supa line e leng gore is at 90 degrees. Ele dotted. I get mara le ke go ira a straight line here. Ke sa re ke yone good. Are you going to net dotted ya no? Go supa gore it's just a normal line, it's not a ray. Lies dotted is but just because it's an imaginary line, it doesn't exist. Normal line here, right? Wanna in eating it dotted, right? It's not a solid line. Yeah, but it has to bend away. It has to do what? To bend away from the normal. Yeah, no, kita lega go supa e leng gore ga e bend away from the normal. Pele. Okay. Hanela gore ke o tsamaya ka jintse. Line ina re tshwanetse wana e hita yana ya kwa here. Me ano statement sa re bends away from the normal. Here is the normal. Away is to the right. So go ra go tsenya line ha the right e benda yana akere tshwanetse gore nne yana lines yana ntse e siana a ke re supile gore e tshwanetse gore nne away ha tshwana re nne mo line e dotted e red akere good yana gore this one is the what incident ray akere ke gona gore simolotseng teng a re tsenye arrow gore simolotseng teng remember ke I for angle of incident, then we run this one ke refracted ray e leng gore e bendile away from the normal yaanong ke tsa gore wa bona gore this red dotted line e supa gore ha ne sa bend e ne ka tsamaya yaanong e boetse ka gore e tshabetse the normal line e boetse ka okay. So this is what we are saying here. So let me remove this line in a little clarify away from the normal. So rain city ke refracted ray. Okay. Ya na entse lora re ya gonna angle of refraction. Ya gonna angle of refraction. So in ya. So this one from air to glass towards the normal, glass to air away from the normal. Fact number 3, the ray along the normal is not refracted. Or a ray hit on the surface at 90, it is not refracted because I is equal to 0. So R is being Hana. It's at 90 degrees to the surface. Here it is at 90, or it is not refracted because the normal line okay. So I is equal to 0 degrees, R 0 degrees, and they are just equal. It was 0 to it. Okay, it's along the what? The normal. Okay. So how will you put in hanga bakare o isupe gore ya go proceed ya baka nna ba go rabare a ba ke wa rabare it's along the normal ba go rabare it is at 90 to the surface of the glass kana ba supile hela na ba supa gore ke 90 wa sa go yo tse dintsi wena ha wa itse gore kana gore guys here is the thing. The reason why super normal, supposing ono irile ya magirele just for clarity, okay? Ki agar eta insa then na okay? Directly after the ray usupain normal is also at 90 to the point of incident ke gone wa go ira ga normal the moment tu ira gone ha ela or normal ke yone ke batla go itse gore yaanong a le gore supposing o le ka go palela wa gore ray e bendela kae towards the normal kana away from the normal because ideally ne ntse ya go tsamaya le gone so it doesn't make sense gore gore kana lo ka re isa kwa how ka re away from the normal ile gore ne ntse tshwantse tsamaya kae ne ntse tshwantse tsamaya kae it doesn't make sense at all. So highly along the normal can I let 90 ya go proceed lines ya like another example is this one hana korara ra go ira ile directed to the center ra go ira ile directed to the center the center ki C ya get so high bend le yone ka gore it's at 90 almost 90 degrees 90 degrees here is at 90 degrees to the surface. It is along the normal. Okay. So ke yone melao e re nang le yone ya refraction e lo re tsentse re itse. So that's enough about the facts about refraction. Re ta di apply in the next lesson. Okay, thank you.